Okay, so I'm going to start here with the normal distribution. In statistics, we deal with the normal distribution all the time. So my goal is always to know as much as I can about anything that I'm asked to work with. I mean, I teach intro stats and we deal with distributions. We talk about z-scores, etc. But until one can really understand a distribution, I think you're kind of lacking. So you need to really go and study everything. So here is a function, right? This is a function, and this is a function for a normal curve. So this will give you a normal curve. It includes x minus the mean, so let mu equal the mean. X is a specific value, and sigma. So if you recall from your intro stats class, when we want to standardize a variable, you can do it many different ways, but one way we do it is, and to make it into what's called a standard normal distribution with a mean of 0 and a standard deviation of 1, we subtract the mean value from whatever value you have and then divide by the standard deviation, sigma. So sigma stands for the standard deviation. So this actually centers everything at 0, because when x is equal to the mean, that's going to equal 0. So that's actually going to center it. So values can be lower than the mean or they can be above the mean. And then this is also, everything's in standard deviation terms. Since you're dividing by a standard deviation, it's a fraction of a standard deviation. So a z-score just gives you distance from the mean in terms of standard deviation. So like a value of 2 would be 2 standard deviations from the mean. A value of 1 would be 1 standard deviation from the mean. And this, if you just look at this ratio, that's exactly what it tells you. Okay, so this is an equation that we use this x value here. We haven't really standardized it is, but I'd like to get rid of this because in discussing a function like this, doing the integration of it would become much more difficult if I have to deal with all this crap. Pardon my language here. So I'm going to want to do some substituting here. Now, to be what's called a probability density function, this function has to integrate to 1. So one thing we know about probabilities can range from 0 to 1, so they can't exceed 1, right? So for this to be what's called a probability density function, and it's called a PDF, or a probability density function, because we're dealing with a continuous variable. If we were dealing with a categorical variable, this would be a probability mass function. So you could probably see that in the videos I did for the binomial and the Bernoulli. Those are categorical variables, or discrete variables if you'd like, and they use PMF's probability mass functions. Here we're using a density function. In a PDF, the probability of any one specific point is 0. It's just that we can divide this density into an infinite number of points. So the probability gets very, very small and approaches 0. So I mentioned must integrate to 1. So I'm going to start in this portion of the video just focusing on how we do this transformation here. So we let z equals x minus mu divided by sigma. So here is the integral, and as I said, it must integrate to 1, but we have this change in x, this dx here, and to change it to this z instead of x, we have to get a dz there instead of a dx, right? So what we do is we take the derivative of z with respect to x, and what we'll get is 1 over sigma. Because x is the only variable here, these just are, mu is going to be 0, the integral of the derivative of a constant is going to be 0. So we get 1 over sigma. So that leaves us dz is equal to 1 over sigma dx. We want to isolate dx, so we multiply both sides by sigma, and then we end up getting dx is equal to sigma dz. So now we can actually replace dx, right, and replace x minus mu over sigma with z, and what we end up getting is z squared over 2, right? So this is it's e raised to z minus z squared over 2. And if you might wonder why is it negative, is because we want this values to slope downwards, right? That's what a normal distribution is, an inverted U. So I want it to slope downwards, and it's squared because we can have values that are negative or positive, so it's going to be symmetrical around the mean. So if you think about that. So we substitute in here. Fortunately, we are able to get rid of this sigma because of this additional sigma we got in our transformation. This scaling factor is important when you're making a transformation. You'll see it when we go to the next phase and we the next phase when we solve for the integral. So ultimately we end up with 1 over square root of 2 pi times the integral, and this is going from negative infinity to infinity. Again, it's a symmetrical about 0 minus z squared over 2 dz. So I'm going to stop the video here, and this is going to be the first part of the video. So this just allows us to simplify our integration, and that's all I wanted to do for now. Thank you, and we'll get ready for the